All right, hello everyone. Welcome to another webinar hosted by Seek and Andy Starnes of Insight Fire Training. Thank you to everyone for joining today. Andy brings a wealth of knowledge and experience from his 30-year career as a battalion chief in Charlotte, North Carolina. So Andy, thank you for being here today to talk with everyone about mixed gain mode, explaining its features and benefits in our firefighting thermal imaging cameras as we talk about thermal imaging 101. If you have any questions, please just type them in the chat and we will do our best to answer them in a timely manner throughout this webinar. With that being said, I hope everyone enjoys it, and Andy, take it away.
Thank you, Jordan. So welcome everyone. We're going to talk about some basics of thermal imaging that may be basic to some and may not be to others. More of what we're actually seeing and some symbology, some understanding of concepts, some things that thermal imaging is used for or maybe is being used improperly for that we've been passed along anecdotally by, we've all been trained certain ways by traditions in the fire service, not saying that they were wrong. It might have been the best information at the time, but we have some information that we hope you glean some learning points from. And I want to thank all of my friends and family who support us as we watch this. I give a shout out to Monroe Township in New Jersey. The Engine 5 is watching today. Thank you guys. So we're going to get started. So as she said, my background is in the fire service. I've been chasing my dad around since I was 8 years old. That's pretty much all I've known. I've worked many jobs in my life, but found that the servant-based role in the fire service is where I belong. I retired last October, so coming up on 1 year. I've been involved in thermal imaging and things of that nature since 2008. Started helping with a project through my father called Kill a Flashover in 2010 with Sean Oak and a lot of other smart people who had invested in me. And that led into thermal imaging curriculum development, product development. We wrote the first collegiate-based program for firefighters in the world, which is now offered through Western Kentucky University and Kentucky Thermal Institute. Is the only online college certification for firefighters for thermal imaging, also backed by Seek Thermal, peer-reviewed by Kentucky Thermal. So please check it out. That QR code right there will take you to that program. It's 2 classes. It's less than about 10 hours, and you can do it for a very reasonable price. And we've made it where firefighters can do it because it's self-paced. So check that out, because our goal was to make everyone have these resources and make thermal imaging available everywhere where it's common knowledge and not something that people have to search for. So my world's pretty simple: my faith, my family, and the fire department, in that order. Unfortunately, I've messed that up most of my career, so hence I have a simple phrase as far as what I do in my life. I work in the dark. I focus on helping firefighters work with infrared or thermal imaging, and I help firefighters with behavioral health issues, because the guy sitting there with the funny thing in his ear had a lot of behavioral health issues. And I help firefighters find those resources with people that I trust, and I connect those resources, and I do ministry work and share and donate a large amount of money and resources back to help people get help, because this guy needed help. And without the support of my family, my faith, and friends that are listening today, I wouldn't be where I'm at. So if you want to learn more about that, contact me after the webinar. I'd be glad to help. Brotherhood's not dead. It's just geographically challenged. Trust me. So let's talk about what we're here to learn about today. Thermal imaging 101, implying that we're talking about the basics. However, the basics are not the basics, because after a study in 2020, we realized that the majority of the fire service is lacking in this area. Of course, we knew that from traveling around the world, that less than 10% of the people we meet have had any formalized training. And 25% of all fire departments in this survey had less than 1 to 3 hours or had none. And 56% of those received no live fire training. Now, the first word in a TIC is thermal imaging camera, implying you need what to train? Thermal. And with the world we live in, we keep restricting training and adding restrictions to 1403 to the point that now we're down to artificial smoke and heated mannequins that will cause training scars and bad results for firefighters. You have to use a significant heat source so they can see the results of these devices, what they can and can't do. And one of the most profound implications from this study was 25% of firefighters were not aware of the temperature measurement inaccuracies. In other words, it's not a thermometer. That number in the bottom right-hand corner that firefighters have looked at as it was the gospel is not. It can be several hundred degrees off, and we'll point that out as we go through this program. Seek is sponsoring the webinar, so we want to give you resources from their devices here. They have the Fire Pro 200, 300, and Attack Pro series. We have custom made resources for the 300 all the way up to the Attack Pro Plus that you can watch for free on our YouTube channel. We have over 15 hours of Seek Thermal webinars, one link on our page, which is also available through this webinar. And you can learn about any of their products or reach out to us or Seek Thermal to learn more. Thermal Imaging 101. So let's talk about what is being detected, what is not being detected. What are these weird words and concepts that I hear all the time, and how should I properly interpret this data? You look at this simple image of firefighters entering into a burn building, it's black, gray, white. And a lot of firefighters would disregard that white area, not thinking that's hot. Those are known as convection currents. We call them convection currents, even though they're not actually convection because the camera sees radiation. But it looks like moving fluid coming across there. Differences in temperature. We can see the thermal layer, and the camera interprets that black, gray, white image through 256 shades of grayscale, whereas the human eye can only see 30 shades of gray. That's the average female, and the average male can see 10. So it's important that firefighters understand that interpretation is the key to success, and how you interpret that and knowing how your camera works is a big part of that. And knowing what your camera is actually seeing is where we should begin. First of all, let's start with what our eyes see. We see a very, very narrow spectrum of light. When I first started reading about light and infrared, I was shocked at what I didn't know, and I'm still shocked because as you learn more, you realize that Solomon says, much wisdom comes much sorrow. Visible light is a very narrow spectrum from 380 to 780 nanometers. You see the Roy G. Biv acronym where the human eye sees colors in those spectrums. So less than 1 micron of range does the human eye see. Whereas if you look at all the other areas of visible and non-visible light, infrared, the long wave infrared, which is what the fire service camera sees, is 7 to 14 microns. That's a lot more than what the human eyes actually see. And that is where the majority of heat transfer takes place. There's also short wave or near infrared, mid wave infrared, and long wave infrared. Then you have other things like ultraviolet, X-rays, gamma rays, microwaves, radio waves. But as far as we're concerned, we can see visible and we can see long wave infrared through the use of a fire service TIC. That does not mean it sees gases or sees through things. We're going to highlight that. But to put it in perspective, our eye is seeing less than 1% of all light. Less than 1%. 99% of stuff going around us we never see. So why would we not carry a device that allows us to detect that range of heat transfer to give us diagnostic data to help us be more successful in our fire ground strategies and tactics? Why wouldn't we? Because I have a lot of firefighters who still refuse to carry this device. They almost view it as cheating. And I'm pretty sure the military doesn't view an infrared or night vision scope as cheating when they take out the bad guy for our safety. Make sure you use everything you have to help the good guys. Let's talk about the 2 types of thermography in this world. Right now, you can group all the thermal imaging into 2 types of thermography. Thermography is the study or non-contact or remote temperature measurement. In other words, I want to measure something, but I don't want to touch it. So I can measure it from a distance, I can measure it close up or far away, but there's 2 types, quantitative and qualitative. Quantitative is exact measurements. Those are industrial cameras that allow or require specific training. Like all of my instructors have to have at least a level 1 thermography industrial certification. If you want to get into accurate temperature measurements for quantitative use, you need to be a level 2 or higher, which means you would be at about 64 hours of training, up to 96 hours of training to be able to do that. And you're using a specific type of camera that's not a fire service camera. Hence, fire service cameras are qualitative. We're looking for thermal patterns, recognitions, and they have grossly inaccurate temperature measurements. Let me say that again, grossly inaccurate temperature measurements in the bottom right-hand corner. See that little measurement says it's 91 degrees? What do you think's over our head right there in that doorway there at IFRT in Germany? Give my shout out to Stefan and the cadre there. I love those guys and gals, wonderful people. If you're in Germany, you need to check them out. But look above your head there. In survey mode, this camera showing yellow at 150, red at 300. Now, is that how hot it is? Or is that an estimate? It is an estimate. It is a scientific guess, and we're going to show you why. So when we look at fire service thermography, which is my definition, by the way, what is detected, what isn't being detected, fire service thermography detects long wave infrared, and manufacturers now are adding things like edge detection and software enhancements. So it's no longer just infrared. And we've got some coming out with AI and lots of other features. So unfortunately, it's not even just infrared anymore, but infrared is the base model where we get our data from. And that is between 7 and 14 microns. Micron is a millionth of a meter. That's pretty darn small. And that's detected upon the surfaces of objects and displays patterns and varies in colorization, get this, based on the manufacturer. You don't get to choose. The manufacturer decides, and none of them have agreed, which is very concerning. If you have 3 or 4 different cameras in your department, you can have 3 or 4 different interpretations. And I'm going to show you why that's not a good idea. What isn't being detected, they don't see through objects. It's not X-ray vision. The movies don't help us with that. Even some fire service shows do us a great disservice of showing what ticks do. I can't even watch the shows because I start yelling at the TV. My wife says, "You're ruining my show." I'm like, "I know, I can't watch this." And they don't detect gases or smoke temperatures. Smoke is not necessarily a gas and has particulate in it. There's a lot of argument in the scientific community about cameras being able to detect it. It may detect certain parts of it, but until someone gives me an accurate research paper that shows me that it detects 100% of those particulate aggregates and aerosols in it, I'm not going to teach firefighters to use it to measure smoke, because I can show you smoke that's much hotter than the surfaces using an optical gas imaging camera and thermocouples, and the camera can be way off. And as I said, temperatures can be grossly inaccurate depending on many variables that we cannot control. It is not a lab. This is a diagnostic tool to help us determine where the problem is, kind of estimate of overall severity, where the fire is, the thermal layer, where could victims be, the pathways to victims, which is more important. Learning all of that through proper scanning techniques and proper interpretation is key to this. If I could teach you anything, it would be to identify patterns and learn to scan properly. That is where firefighters mess up more than anything out there, is they scan like Luke Skywalker in a lightsaber. Your camera can't respond that fast, and you can't interpret that fast. As Chief Mike Mitchum taught me years ago, take some seconds to win some minutes. Take time to make time. Some other limitations of these devices, as I said, they don't detect gases, and shiny surfaces can throw you off, from reflections to inaccurate measurements, whereas rough surfaces, the camera detects those very well due to its programming and settings. And it gives grossly inaccurate temperature readings. And older cameras prior to 2013, before NFPA 1801, may not have the luxury of something called an EMI coding, electromagnetic immunity coding, which can cause radio frequency interference. When you key up your radio or your portable, it could literally make the screen lock up. Now, that shouldn't happen on newer cameras, but I've seen that happen due to human nature not properly installing those coatings on all manufacturers, not just one. Because the same flawed human beings work the same jobs we all do. And the biggest limitation, ladies and gentlemen, is the end user. Just like looking down this hallway, someone would say it's only 97 degrees, we can go. Well, I'm not saying you can't go, but I promise you it's a lot hotter than 97 degrees down that hallway. You have to read the big picture. You don't drive down the road looking at the bottom right-hand corner of your windshield. You look at the big picture. You turn your head at the intersection and you look, because you don't want to get hit by an oncoming car. So we need to look at the big picture and interpret the data in real time. Let's talk about some common misuses of these devices. A lot of fire departments have been lured astray by certain color palettes that have the word hazmat mode. I can tell you with absolute certainty that fire service ticks are not hazardous material cameras. They can be used in many ways to help you with proper training, but here's the downside of using a fire service tick in a hazmat scene. Many of them are not intrinsically safe, and there's only one camera that I know of that is not a fire service camera that's ATEX certified, which is explosion proof. So it could become a potential ignition source. That's a big deal. By the way, so is your iPhone and your smartwatch. So if you're worried about intrinsic safety, can't carry that on the fire truck. These devices do not detect vapor clouds, but can detect thermal patterns of heat transfer or fluid levels or non-insulated containers. There are many gases that cannot be detected while they're leaking, but when they burn, you can detect the heat from them, such as alcohol, hydrogen, things of that nature. But you can also detect the patterns of things when they're leaking as far as when they affect a surface, which we'll show you some examples. So thermal patterns, colorization, convection currents, or even the indication of low sensitivity in many cameras can become visible when using it in a hazmat scene, but I would use it from a remote location. The better use for hazmat would be UAS solutions where you're flying remote over it. with different sensors. They make optical gas imaging for those cameras. They make remote monitoring. They even make tunable laser diodes where they can measure something with a laser from a remote distance. As far as fire service cameras go, some of the features you would see that are beneficial, such as survey mode by Seek, search and rescue mode by FLIR, hot area detector or cold area detector by Bullard, or the electronic thermal throttle by Bullard. Those are just a few examples that could be beneficial to you if you understand those features, which are specialized application modes, which are called TI Basic Plus if you study NFPA 1801. One of the things that I have to deal with on a regular basis is seeing things such as people using cameras improperly and trying not to respond in an inappropriate way, because my father's taught me, son, you didn't know any better 20 years ago either. But there are individuals teaching firefighters to crawl under vehicles and point the camera at the battery and measure it. Number one, study batteries and look at how well they're insulated. Number two, there are skid plates and other things that can come between it. Number three, the manufacturer will tell you that thermal runaway cannot be accurately detected by the spot temperature. And it is not recommended to get under a car and point the tick at the barrel of a gun, such as the battery casing. These casings are extremely well insulated. People that give you exact numbers like 150, 250, 140, I've heard numerous ones, are guessing based on experience, because not every battery casing is the same, not every car is the same. But when you see things like thermal patterns, colorization, convection currents, or low sensitivity indicator that may be visible, that's a bad sign for an EV car. So you would be better used to use something like those specialized application modes, such as search and rescue mode in the FLIR, survey mode in the Seek, hot area detection by Bullard, or their electronic thermal throttle. But remember, please, heat signatures on an EV battery through a tick are a very late sign of impending failure. And we don't have the right device to look at that. This is from one of my friends who does a lot of work with that, Webb Marshall, showing a lithium ion battery on fire. You watch that spot temperature jump all over the map, and you will notice that the actual burning area is showing between 300 to 1,000 degrees Fahrenheit. You think it's actually hotter than that? I'm going to give you a solid yes. So spot temperature measurements prior to thermal runaway are often low and can lead to injuries or death. How do we know that? Because sadly, firefighters have done that, and it's been to close calls that have led to almost killing people. If you want an interesting read on that, check out the Surprise, Arizona incident that was reviewed by FRSI. This QR code takes you directly to that review, and you will read the following. Incident says right here that at 8 o'clock, the team opened the door to an energy storage system, which is a big box of batteries. The captain put the right foot over the door threshold to gain optical access to the line of racks using the tick. The captain declared a maximum temperature of 104 degrees Fahrenheit with no active fire or visible arcing. This picture was taken 3 minutes before deflagration. At the moment of the deflagration event, the firefighters outside the hot zone described hearing a loud noise and seeing a jet of flame extending at least 75 feet outward and estimated 20 feet vertically from the southeast facing door. In the event, the captain and the firefighter engineer were ballistically propelled against and under the chain link fence that surrounded this system, and he came to rest 73 feet from the open door. 73 feet. The firefighter came to rest approximately 30 feet from the door. The other firefighter was projected toward a transformer distribution box and remained within the fenced area. The entire hazmat team lost consciousness in the deflagration event, and the event also dislodged or removed their SCBA face pieces and helmets from all hazmat team members. What are you dealing with here? This is not a regular Class A fire. It should not be treated as such. Keep that in mind, because we are way above our head when we're dealing with these with a fire service tick and not understanding the power of these things. So let's talk about the danger of the spot temperature in reality. My friends at Kill the Flashover would appreciate the candle reference, but this picture is a candle reference, a crude one, showing approximate temperatures of an ordinary candle. A candle flame can reach 1,400 degrees Celsius on average, which is close to around 1,800 degrees Fahrenheit, firefighter math. But if I point a fire service tick at it, it will tell me it's anywhere between 800 to 1,200 degrees. Why? Number one, that camera has predetermined measurements and has a max dynamic range. Does that mean it's measuring that flame accurately? No. If you want to learn more about that, We have an article called The Danger of the Spot Temperature article. It's our #1 most read article on our website, which quotes why NFPA 1801, the thermal imaging camera standard per NFPA, removed the spot temperature from TI basic, due to it being listed as a contributing factor in 3 separate line of duty death incidents. In addition to that, numerous reports of firefighters have misinterpreted the thermal environment based on the spot temperature, and that has led to rekindles and injuries. So if a candle flame is close to 1800 degrees, and you look down the hallway and see some flames, your camera's saying it's 500 to 800 degrees, you need to know that's what we call an estimate. And it's much, much hotter than that. It's something we use to diagnose conditions. And you need to read about the limitations of your turnout gear in reference to what that does to you if you ignore that. So, oops, hit the wrong button, sorry. So let's look at what we need to know. Whether you know it or not, NFPA 1001, the firefighter qualification standard, is being updated to NFPA 1010. And with that new update, it requires all new firefighters to have requisite knowledge of operating procedures and limitations of thermal imaging cameras. I would believe that is more than most of America has, requisite knowledge, knowing that simple bullet point A. And it says you have to do 3 things as a new recruit firefighter. You have to be able to operate a TI, given a tick with SOPs, PPE, and assignment, and you have to locate a victim in obscured visibility, hotspots identified in structure, overhauls completed, and liquid level in a container is determined. That last one can be a little gray area because containers are not all the same. And please don't use artificial smoke to train firefighters to recognize a victim. These objectives, ladies and gentlemen, require live fire training, like this Fire Pro 300, showing us looking down the hallway, briefly cooling the hallway, and showing us erasing the color, so to speak, and watching the convection return in what we call a thermal rebound drill, where we can force a rebound and diagnose the direction, level, and intensity of the fire, where it is. We can also see the hose line in the floor, the boot of the firefighter sitting there taking it easy. You can also see the convection is not just moving towards the open nozzle, it's also moving up the stairs in this Draeger container, which we spend a significant amount of time in metal trash cans. So I can tell you a lot about those. But this is what's required of all brand new firefighters. And the majority of the United States and internationally does not know this. So we have to do a better job of sharing, educating, training, and helping firefighters. So here's some terms and concepts to remember as you move through here. Probably the most confusing and difficult word to say is emissivity. We'll talk about that. We're going to talk about atmospheric attenuation, what can interfere with the camera's ability to measure something. Temperature modes versus application modes. I've already given you kind of a teaser about application modes like survey mode, search and rescue mode, electronic thermal throttle, hot area detector. Those are all features that manufacturers offer to find things. They're considered investigative modes. And then the concept known as convection currents. We need to understand that. We use the Max Firebox as what we call a small scale prop after we do a brief classroom to show some of these concepts. And emissivity can be easily shown because the side of the box is made of diamond plating. So we can get this box very hot and they can stand to the side and read the spot temperature and realize that that box is obviously not 70 something degrees. So what is emissivity exactly? It's the ability of an object to emit, absorb, reflect energy numerically between 0 and 1. You're like, what is that? Well, 0 is a mirror. And 1 is a perfect black body or perfect emitter. And according to scientists, there is no such thing as a perfect emitter. However, all fire service cameras are programmed or preset at between 0.95 and 0.97 emissivity, which is the same of many carbonaceous objects such as human skin, soot, rough surfaces, wood, etc. But that was pretty common when these were first made. Now, many household items are not 0.95 emissivity. Think about how many shiny surfaces are in a home today. You can't buy an appliance that's a matte finish hardly anymore. You can't buy a washer dryer that don't look like a sports car. So there's many reflective surfaces in our homes and buildings. Think about a commercial kitchen. Think about going in warehouses. Many places have shiny surfaces that could throw firefighters off. So emissivity is not adjustable in fire service ticks. It is adjustable on industrial cameras, allowing them to adjust for those variables and get a predetermined measurement or an accurate measurement. But we cannot nor do not have the luxury of being able to adjust for those variables. You don't have the time to look down the hallway and say, oh, it's 30 feet away, it's 72 degrees in here, wind speed 3 miles an hour, the wall is 0.96 in emissivity, the reflected apparent temperature is 68 degrees, and it's looks like about 60% relative humidity, and we'll program that into the camera with my oven mitts on, as Rob Ramirez says. No, you don't have that. You don't have that luxury. So the following chart demonstrates how inaccurate these devices can be if we're simply relying on direct temperature measurement. If you look, follow the 0.1 emissivity upper left-hand corner, that is the same as a polished stainless steel appliance, such as a stove or a refrigerator. If you follow this chart all the way over to the number 400 degrees, we'll go between 3 and 400 because according to UL's thermal classifications, an ordinary temperature classification is 392 degrees. So we'll say firefighter math, it's 400 degrees, looking at an area that has a shiny surface. If we did the math, ladies and gentlemen, the actual measurement would be 996 degrees. That is quite a variance. I wish the bank would give me a $596 allowance every time I make a mistake, right? And it doesn't work that way. Cameras give you estimated values, not exact measurements. So when we teach something called go, no go decision making, we're looking for apparent temperatures, not exact measurements, because we know it's hotter than. And why is this important? Because this is a perfect example through a FLIR camera looking, this is an old K50 actually, looking at the side of a Max firebox, which is diamond plating, but it has a cutaway through the steel behind it. In their search and rescue mode feature, just like survey mode in the Seek camera, you start to see colorization early at 200 degrees. But notice this, the actual diamond plating is measuring 70 degrees Fahrenheit. That is the reflected apparent temperature of the environment you are in. You can do this same drill with a shiny pot in a firehouse kitchen with electric tape on the pot. Every week, every firehouse in America is going to make pasta or potatoes, guaranteed, because it's cheap. So when you get the water boiling, you stand back 6, 8 feet. Don't stand closer than 3 feet because most cameras can't focus in on that. And I want you to measure the side of the shiny surface when water's actively boiling, steam's coming out of the pot. Tell me what the direct temperature measurement, where that little square is, and what the measurement says on the bottom right-hand corner. It will be close to the ambient temperature of the room. Then move that little square over to the electric tape and tell me what happens. Electric tape is closer to 0.95 emissivity, which is what the camera's programmed to pre-calibrate it at to measure, and the temperature will skyrocket. Because that's how most of us thermographers use electric tape to cheat. We figure out the emissivity of a surface by using electric tape. So the question you should ask ourselves after hearing me ramble all this time is, if we cannot use a tip for temperature measurement, then what can we use it for? We can measure apparent temperatures, which are estimated values for diagnostic purposes. If I had to start over, I'd just try to teach people patterns. Just look for patterns, non-uniform, things that are not supposed to be there. It's not going to be a square or circle in many cases. It's going to be an abnormal pattern showing heat transfer. We look for those superheated areas or hidden fire or convection currents or signs of heat transfer from one area to another through a concept known as thermal bridging. That's an area of weakness where it's transferring from an interior wall to an exterior wall through that weak point. And we can detect severe levels of heat in certain cameras through colorization, convection current identification, and noting the low sensitivity indicator in every camera except for Seek, because Seek uses something called mixed gain mode. So you don't have to worry about looking for when it switches. It's doing it automatically. Remember this if you're trying to identify those concepts. Convection can lead to direction, and colorization can provide information, because you may not always have convection currents. You have a door closed and have an unusual heat signature on that door. The door might be open, and when you open the door to the fire environment, you create a flow path, therefore heat transfer occurs, and you can literally read it and follow it right to the fire. Some other things when we talk about what can cause a camera to have issues, it's called an atmospheric attenuation. In other words, interference between you and the target. What could mess up that camera's ability to measure that area? Biggest thing, moisture. The lack of firefighters understanding moisture on the lens is a huge failure point. I've talked to hundreds, if not thousands, of firefighters who've experienced whiteout on a camera and never knew to wipe the lens. They wiped their face piece, they wiped the screen, they never wiped the lens of the camera, and the camera went gray or white. They became extremely frustrated, injured, or worse. When you pick that camera up, wipe that lens with your non-dominant hand, because your dominant hand's going to be down in the dirt probably, and then wipe your face piece to look at the screen. If necessary, wipe the screen. The optical density of the smoke can have a difference. If we're burning tractor tires versus standard Class A materials, you may not see as well. Extreme heat can affect a camera. Wind can affect a camera. distance, like in this picture where the firefighters move down the hallway and down, if one's gone, one's out of the way, and we're looking down that long hallway, a lot of moisture in the smoke at a big distance. That's called washout. The images are starting to match that background temperature. It's very difficult to see. And the failure to wipe the lens and convection currents all can affect how you see, because if the convection currents or fast moving smoke is blasting you in the face and also blasting the lens of the tick. By the way, the germanium lens of the tick and your face piece have very similar failure points. Neither one of them like heat. Keep that in mind where you stick it, okay? And when you talk about how the camera sees heat, it sees it like the human eye does. The eye goes from dilated to constricted based on light, and your camera changes modes or temperature modes based on heat. And there are many cameras on the market, so we gave you 4 ways that they all work. There's single gain modes, which is usually special application modes designed for low temperature, such as search and rescue mode in FLIR, survey mode in SEEK, thermal scan in Draeger, size up mode in Argus, or overhaul mode in Argus. Dual gain cameras are predominantly the majority cameras on the market. They have a green triangle that shows up the upper left-hand corner when they see a lot of heat, switching to what's called low sensitivity. NFPA defines low sensitivity as low sensitivity to detail in the presence of higher heat. So when that triangle shows up, triangle's pointing up, your butt should be down. Older cameras prior to 2012, you may see other indicators prior to NFPA, such as EI, which stands for electronic integration. My favorite was the Scott Eagle Attack, which just said hot across the top. MSA, the older ones, had a blue L that showed up in the lower left-hand corner, and the relative heat indicator or color bar turned blue, which is very hard to see. Then you had cameras that split the overall temperature range into 3 spans, which to me is very confusing. The Scott X380, Leader, and Argus all currently do that. Scott X380 is no longer in production. Mixed gain mode, which is each pixel switching automatically, which is the smartest, simplest, safest, and fastest way on the market, is made by SEEK Thermal and used by these other manufacturers in their products. So you will not see a triangle because each pixel switches back and forth between high and low sensitivity on its own, which is faster, simpler, safer, and I don't have to look for a triangle, and I have less loss of detail. It is the easier way to deal with a dynamic situation without having to address or look at icons or buttons during that environment. And if you want to learn examples of that, whether you have a SEEK camera or not, we have a FLIR example, a Bullard example, a SEEK Thermal example, and those of you who use the Tri-Gain, the Scott X380 is the most common one we run into. These QR codes take you to those videos explaining that, and per NFPA 1408, which is the thermal imaging training standard and maintenance standard, it says that we shall understand these functions and modes and use of accessories being used by that camera. So your question you should ask your firefighters is, do they understand this? Because they don't understand how the camera sees heat. They don't understand the heat they're looking at because they're waiting until they feel heat, which is a bad idea with today's turnout gear. By the time you feel pain, the victim's dying or dead in pajamas based on the gear we wear. So how do the other cameras work, and how does the SEEK camera work? Each camera is going to switch, and how they switch is different, and how much energy it takes is proprietary and set up by each manufacturer. So SEEK does it pixel by pixel. One pixel highlights 302 degrees, it will colorize yellow. For my friends overseas, 150 degrees Celsius, it will colorize yellow. If the pixel next to it is cooler, it will stay black, gray, or white based on the amount of energy hitting that pixel. That is SEEK's proprietary system known as mixed gain mode. Pixel by pixel, it is the fastest and most sensitive on the market. FLIR will be the next with 2% of the pixels at 150 degrees Celsius or 302 degrees Fahrenheit. When that happens, the camera will pause for 1 second and then switch over, and the triangle is visible in the upper left-hand corner, and colorization begins at 150 degrees Celsius or 302 degrees Fahrenheit. Bullard takes 3% of the pixels at 230 degrees Fahrenheit, a lower temperature setting and faster than FLIR, and allowing you to see that much earlier, but they don't show color until 500 degrees Fahrenheit or 260 degrees Celsius. They have amazing grayscale, but late colorization. Their new QXT Pro is extremely impressive. The Tempest Leader cameras and cameras above that, Draeger and all that, some of them do not publish how much energy it takes. I know Leader takes 5% of the 110,000 pixels for it to switch, and the MSA 6000 Evolution Series camera, which is no longer in production, takes 32% of the pixels at 290 degrees to switch, which is a large amount of pixels. A lot of people know this data, but they don't know this. If I'm going to point it back down at the floor at a cooler environment, when will my camera switch back, and why or why will it not switch? Which camera will show cooler areas and hotter areas better simultaneously, and why? So using mixed gain mode with this victim in the floor from my friends in Ohio who sent me this video, you can clearly see the mannequin and the heat above them due to mixed gain mode. It's automatically adjusting. That is mixed gain mode, does it pixel by pixel. Where FLIR takes 98% of pixel saturation at 122 degrees Fahrenheit or below to go back to high sensitivity. Think about that. How much cooler does that environment have to be to force the camera to high sensitivity? Bullard takes 97% of the pixel saturation at 158 degrees Fahrenheit or below to switch back. MSA takes 89% of the pixels at 248 degrees. Keep in mind, this is all within the field of view of the camera or below to switch. In other words, where I point it matters, because I can point it in there and fool the camera. That just because you don't see heat doesn't mean it's not there. So this is the data straight from the manufacturer's instruction manual on how these devices work. So NFPA also tells you in 1408 that if you're going to use a camera, you need to know what all these fancy colors mean. So you need to know what the color temperature correlation is. In other words, what color means what, and what does the absence of color mean? So my friends who use Celsius or Fahrenheit, just keep in mind that the colorization will still engage based on those programming features. If you have a seat camera, there's a little pin portion in the middle between the power and the flashlight button. Push it with a paper clip, it'll switch it between Celsius and Fahrenheit if you're having problems with that. So let's talk about, what does NFPA require all cameras to start up with as far as colorization? It's something called TI Basic. NFPA 1801 2021 edition 6.6.4.1.9 tells you this information about TI Basic. It is a lot of information about the symbols and all the things in there, but it also breaks down, when I turn the camera on, when am I going to see color and why? The color palette consists of black, gray, white, yellow, orange to red, progressing from cold to hot, which sounds amazing. But unfortunately, this is where they allow the manufacturers to kick in. No more than 50% of the overall heat color reference bar shall be grayscale. It doesn't say heat color, it doesn't say dynamic range. Keep that in mind when you look at certain cameras, because they've gotten out of some loopholes that way, or exploited some loopholes. In other words, if I have a 1022 degree range like a seat camera, then no more than 50% of that can be grayscale. Well, seat kicks in at 302 degrees. You look at a FLIR, it kicks in at 302 degrees. Look at a Bullard, it kicks in color at 500 degrees, so they're still within the range. There are some other ones that are outside of that range. You figure that out on your own. But when you're looking at the actual camera, if you go into another application mode outside of TI Basic, there'll be a plus indicator in the lower left-hand corner. That is a requirement to tell you you are not in TI Basic anymore. You are in an application mode that is set by the manufacturer. If you need to toggle back, please don't toggle. All the ones that are compliant or certified to this standard, all you have to do is tap the green power button one time, boom, it goes right back to TI Basic. If you'll notice on the newer cameras from 2021 on, NFPA certified ones, the spot sensor is not there in the lower right-hand corner. You have to physically go into TI Basic Plus to engage it back. I gave you the reasons why, but I highly recommend you share that information with firefighters, because most do not know that. We did an entire webinar on NFPA 1801 and the Attack Pro Plus, which you can view right there to refresh your memory on it. And keep in mind, those of you who are required to buy NFPA certified cameras, a lot of you are using AFG grant monies, and that is why. If you read the grant application, if you're buying specifically a TIC and not using something as an accountability system or another type of loophole for getting the grant and buying cameras, if you're buying cameras, specifically cameras are your grant, NFPA 1801 says they shall be, or AFG says they shall be NFPA 1801 certified. So if you want that, there's a cheat sheet on my website. It says, using AFG funds, please read this. And it goes through the actual document and tells you what to look at. Don't make the mistake of just buying any camera with government funds, because you could get in a lot of trouble that way. When we look at those icons and symbols that TI Basic talks about in Chapter 6 of NFPA 1801, you'll see on the Seek Attack Pro here, we have a few of those indicators, but not all of them. We have the power source indicator, which is your battery bar. A minimum should be 25% per bar at a minimum of two hours of battery life. Well, the newer cameras are going 6 to 8 hours, such as the Seek. If your camera shows a red flashing bar, you have typically less than a few minutes left of battery life. Some of them are 5 minutes, some of them are 30 minutes. But I would tell you, if the battery bar is flashing, you are in trouble. Don't go into a fire with less than 50% battery life. That's just my recommendation. The bar on the right-hand side has a heat color reference bar. You'll see that it goes from black, gray, white, yellow, orange, red. If it's an NFPA compliant camera, it also has this green bar going up and down, trying to give you an indicator of where you are. I'm not a big fan of that. I think that's just kind of confusing because you move, it's dynamic. You're not stationary in filming. The bottom right-hand corner is called the numeric temperature indicator, which is the spot temperature. If you look for that gray or that green box in the middle, that's where that measurement's coming from, which is predetermined from a lab setting. You need to know the distance that it was set at. A lot of them are set really close, a lot of them are set far away, and none of them are set in a fire environment. Some other icons that are not here that you need to be aware of: any other camera on the market besides Seek, if it sees a lot of heat, the camera will pause and a green triangle will show up in the upper left-hand corner. Some of them are faster, some of them are slower, but you will see a green triangle with a green box in the upper left-hand corner indicating low sensitivity mode. That is not on a Seek thermal because it happens automatically. You need to understand that any other camera that has a green triangle, it's trying to warn you that that camera is viewing a large percentage of heat. If you happen to see a red dot with a green outline in the lower left-hand corner of that plus indicator, that means the camera is recording. Let me say that again. It is recording. If you do not have policies on recording, you need to look that up. You look at the FOIA Act and what that means, the Freedom of Information Act. If you see a red triangle with a thermometer show up in the top center of the screen and it's flashing, that is the overheat indicator. That is bad. That means the inside of a vacuum seal insulated device is overheated. And these devices, decision-making cameras specifically, go through a lot of testing to make sure that doesn't happen. And in 16 years of doing this, I've only done it to one camera, and we were doing something stupid. So I'm not going to blame the camera for what we did. So an overheat indicator on most cameras that are NFPA compliant means the internal components are over 260 degrees Celsius or 500 degrees Fahrenheit for 5 minutes. That's internal temp. You're melting the bail of your nozzle at that point, exterior. So be aware of that, please. These are a few things you can find in the NFPA document, which has this really fancy black and gray, white, lots of numbers and icons. I tried to simplify it because I thought that was a holy information overload, Batman, looking at that. But one thing I want to stress when we're talking about colors and icons and things of that nature, if you look at this video, the Fire Pro 300, we had to invert it because it was hanging on a coat. I want you to see where the color is, but I also want you to see what's moving past the color across the ceiling. And remember, the absence of color isn't the absence of heat, and we can use convection currents to our advantage. Because one of the number one things you can hear on any fire ground when things start to go wrong is one of Don Abbott's top 25 contributors to Maydays, which is, we are having trouble finding the fire. Well, right there, there's the fire. But what's coming out of that door, moving over your head or hitting you in the face piece that you can't see because there's no color? It's a nice reflection on the floor, too. This is in Macomb, Michigan, thanks to my friend Chris Gruner, who built an awesome setup for us. Shout out to him. But the other thing that a lot of departments don't even take into consideration, and this is just another point for you to think about from training, is 5% of America is colorblind. You hear me? 5%. And a lot of them are blue-green, red-blue. There's lots of different versions. There's a $5 app you can put on your phone called the Colorblind app. And I had to learn the hard way that my wife was right. I've been arguing with her for 20 years about a chair in our house. I say it's green. She says it's blue. Well, guess what? She's right, because I have trouble seeing between white, blue, and greens. And I didn't know that until I took this silly little test. Well, if they can't see reds or greens, what is every icon outlined on a fire service tick with when they start something TI basic? Green. What's the first color that shows up when the camera gets hot outside of white? Yellow. If they can't see yellow, you might want to work with them and ask them what they see and write down their version of the color palette. And that way they can interpret it under stress without a designated adult telling them what they see. But just please be aware that convection currents, the height of them, if you're not paying attention, you're crawling in a full exhaust. Numerous line of duty deaths have been pointed out where firefighters died in a unidirectional flow path. That's a full exhaust, and they were unaware of it. Many variables why, but when ticks were used, they did not understand what they were looking at. They did not know that that fast-moving gray-white stuff was an oven. NFPA 1971 uses one specific test you ought to look at called a forced air oven test. You heard me right, forced air oven. That's a convection oven. That's what you're crawling in, okay? And why should we take all this data and go back to our fire department and say, hey, chief, we have 5 different cameras on our fire trucks. Maybe that's not a good idea. And you're like, why do you care? Well, we don't have 5 different types of hose all in the same pre-connect, because when you put all these cameras together on one fire ground, here's where you end up with varying resolution, ages of pixels and programming, varying color palettes and temperature associations. In other words, they're not going to show the fire the same. Display quality may not be the same. Varying gain change algorithms, which interpret fire scenes differently, that some of them may respond early, some may respond late. Some of them may not show colorization until over 1,000 degrees Fahrenheit in low sensitivity. If you're waiting on color with that particular device, you're in trouble. And then some of them have varying distance to spot ratios. In other words, their effective range to measure something. Some of them are as little as 7 feet. And some of them are very, very far away, which is what I want, something that can pick up something far away and give me an early or warning. And then the other thing that's all grossly overlooked is the thermal sensitivity rating of the camera. If you look at the NFPA standard, it says it shall not be greater than 80 millikelvin. You're like, what does that mean? A millikelvin is 1,000th of a degree. The lower that number goes, the better your chances of seeing objects of similar temperature side by side and making out what they are, like a small child's hand next to a pile of stuffed animals. So it's important you understand these terms and definitions and how they apply to what I call the tactical side of your life. And most importantly, you put all this together, you end up with varied interpretations. These are 2 cameras looking at the exact same fire and very different interpretations, but both are showing the same environment. It's all about the programming, not the camera's fault. Person's holding it. If we know how to use the camera, apply it appropriately, we can be what we call intelligently aggressive and not miss things. One of the concepts I highly recommend you look up when I mention terms is something called a thermal bridge. It's a fancy word for conduction. When engineers build a building, they don't want energy to leak out of the building. When you get a new home, they pressure test the home to make sure that you're not losing energy. You get an energy efficiency rating. You probably saw that when you bought an appliance. It'll have a yellow tag and it'll say, cost this much to operate per year. Well, the same thing's on windows and things of that nature. Well, a thermal bridge is also known as a heat bridge. It's a weak point in the building where significantly higher heat transfer can occur. Now, if the building is built properly and not on fire, you typically don't see this. But if the building's not well maintained, not insulated, or on fire, some of those points around windows, doors, things of that nature, where they put things like rubber gaskets around a door, caulk around a window, spray foam, that stuff burns under fire conditions quite well. And in this case, the old thing, oh, you can't use a thermal imaging camera to see through glass. Well, it doesn't see through anything. But there's a reason, ladies and gentlemen, we don't put single pane glass in new homes today. Because single pane glass does not stop your precious hard-earned money from going straight out the window. Energy transfer goes right out or right in. It doesn't reflect the energy. That's why when you look at windows, it says low E glass. Nobody reads the E part, E for emissivity. You want some fun reading, look up low E home fires or window home fires, where windows have reflected energy over to another house and caused a fire. Or the Scorchley Tower in the UK, which is over 20 stories high, built in the shape of a concave mirror, and when the sun hit it, it melted bumpers off of cars in the adjacent parking lot. Remember the ant and the magnifying glass as a kid? Yeah, well, somebody got even. So read this stuff and understand that just because someone told you you can't do something with a tick, if you understand the context, the contraindications, and know more about what you're looking at than what you're looking through, you can figure it out, just like this is a sign of a fire in the basement. And I have a gee whiz question for you, because I told you in the beginning, fire service ticks cannot see gases. Well, this is a 2-inch gas line cut on a 100-degree day, 3 feet underground. It's the gas line for Walmart. I was the incident commander of this incident. I'm walking back to my car. I point the camera at the ground. I'm like, huh, that's really interesting. That dark looking finger thing sticking out of the ground is an orange pipe where they would run their cable. Well, that V pattern is where the gas that it was pumped from the manufacturer at 58 degrees Fahrenheit and then underground, which is also insulated, as it leaked through the ground, it cooled the surface of the hot dirt. We didn't see the gases. We saw the effects of the gases. Remember that, pattern recognition. We may not see the vapor cloud, but this can lead us to the problem. And that's what I want people to learn. If they can recognize these issues, they can find the problem. If you want more resources on all this, I highly recommend you check out the following 3 things. Our YouTube channel has been updated a lot. Last time I checked, we had 90 hours of webinars, just webinars alone. There is a webinar playlist. There's a Seek Thermal playlist. There's a Bullard playlist, a FLIR playlist. There's almost every one of them's on there. There's even a new Chinese camera playlist I put on there called the GuideSense camera. And then we have a Seek Thermal resource page, which after this webinar will go up to 16 hours of webinars on our website. And if you want all the presentations and stuff we've done before, you go to that Insight Training Google Drive. Sorry, allergies kill me. That drive has all of our resources for numerous manufacturers. And if you look under the Seek Thermal Public Shared folder, every presentation I have done since we started doing webinars is there, already there. You don't have to call me, email me, just scan it. It goes right to it. It's not locked or, doesn't have restricted access. I finally figured out how to fix that. I'm not I teach technology, but I'm slow at it. If you scan any of these 3, you will get a ton of resources to help you help your fire department. And that's what we want for you, ladies and gentlemen, is I'm not worried about whether you take my PowerPoint or you go teach. I don't care anymore. You know what I care about? I care about you dying in a fire when you had something on your coat that could have got you home. And a firefighter should not die in a residential building. I'm sorry, you should win. Residential context, we should win every day, and we lose a lot. And I'm tired of us losing when we have the advantage now. We have the knowledge, the technology, and the training, and we want to continue to do that for you. So we're doing another webinar on the topic of mixed gain mode on October 30th. You scan that QR code, it goes right to the registration link and can take you there. And we'll be glad to look forward to that next webinar and whatever Seek Thermal has planned for us after that. We typically do 1 or 2 a month. So you're looking at numerous amounts of free training for you, the firefighter, thanks to Seek Thermal partnering with us. And with that, I'm going to hand it over to Jordan and Brent. And I thank each one of you for your time. That leaves us about 7 minutes left for the hour.
Thank you, Andy. Great information. We do have a question in the chat. Someone says, what would you recommend wiping the lens of the camera with in a fire environment to prevent potential damage to the lens?
A gloved hand. I know people don't like to hear that, but the lens has a DLC coating. It's called diamond line coating. It's scratch resistant, not scratch proof. There are more people concerned about scratching the lens than scratching firefighters. If you don't wipe that lens, you're going to have a bad day. And there are people that tell you should carry a lint-free cloth and all kinds of different things. I have not found a way to keep a clean cloth in a dirty, blue-collar, nasty environment and be able to do that. Until they come up with a self-cleaning lens, our option is to use your non-dominant hand, the one you're not putting down in the dirt, hopefully, which I just use my left hand and wipe the lens. And you have to, I recommend wiping the lens every time you pick the camera up. So when you pick it up and you wipe it, it's ready for use. But if you don't do that and develop a habit of doing that, you're going to have a problem. But when you're back at the station, clean it with soap and water and an alcohol wipe on the lens and the charging contacts. Do not use solvents. You will have a bad day. I hope that answers your question.
Awesome. Well, we just want to remind everyone that we do have a burn program where you can request a free demo unit to put to the test and burn with. The link to register for that can be found on our website or in our Instagram bio. So feel free to check that out and give us a follow on socials. If there was something that Andy mentioned that you wanted to go back and reference, like his thermal resources page that he mentioned, we will also be sending out a recording of this webinar for everyone who attended, so you will have that readily available. But yeah, thank you again, Andy, for your time, and thank you to everyone for registering for today's webinar.
Thank you, Jordan. Y'all have a great day. We look forward to the next one.
Yep, you too.